Hello, you're welcome back to the part 4 of section 2.8. And here we'll be discussing the graphing of inverse function. So you remember how to find inverse function? What do? We interchange in one of the steps, we interchange between x and y to find the inverse. So that will give us an idea of how to graph the inverse function. So it means that what? Since we are interchanging, so it means if you have a point AB on the graph of f, then this simply means that what? The point BA will be on the graph of what? Of f inverse, right? So this is how to interchange the points. So if you have BA on the graph of f, you interchange it to what? To AB on the graph of f inverse. So, but we get the point B, comma A from the point AB. How can we get B, comma A from the point AB? This is simply by reflecting across the what? The line y equals to x. Now look at it. If you have a point, look at this point. This is point B and A. So if you put the line y is equals to x here, this point, if you reflect it across this line, this point will become here. But here, what will it be? It becomes A and what? A comma B. So it means that if you want to graph the graph of inverse, it's okay if you reflect the original graph, which is the graph of f, you reflect it across the line y equals to what? Y equals to x. So that will give us the graph of f inverse. In other words, if you can interchange every point on f, pick some point on f, then switch the point, then you will get the graph of f inverse. So let's see this one. Let's try to do this one. Example 11, it says sketch the graph of this function. We know the graph of this function is just what? This is just the graph of f of x is equals to root of x. But now, because of this -2, it means it is shifted 2 units to the right. So this is something like this. This is the graph of f of x equals to x minus 2. So we want to use this graph to sketch, the B part says use the graph of f of x to sketch the graph of what? F inverse. So now what we're going to do to sketch the graph of f inverse, we're going to do it 2 ways. So let's do this more. So actually we can do it this way by just drawing the line y equals to x. So let's draw the line y equals to x. So the line y equals to x will be something like this. So this is the line y equals to x. So all we need to do is to reflect this red line, the graph of f, across this line. So as you can see, we have an idea here. Here you can see a point 20. Definitely on the graph of f is going to be 0,2, which is somewhere here. And it is clear to see that this will just open up as well. It will just open up something like this. So this will be the graph of what? Of f inverse. Now, in case you cannot see the reflection easily, what do? Just take what? Take numbers or take, yes, take points. So let's take points so that this can be clearer. In case you cannot see this reflection, if you reflect this red one across this line, it will just be this one. But if you take points to do that, let's take a point on f and let's take a point of F inverse. So you can start the easy one, which you can see. This one is very easy, which is 0.20. But on the graph of F inverse, it will become 0.02, which is here. Then we can also take some points. Usually you take a point that is very nice. Remember your function here is root x minus 2. So we can take x to be maybe, if you take x to be 3, yes, if x to be 3, y is going to be 1. But this is on the graph of f, right? On the graph of f. Then on the graph of F inverse, this is going to be 1, 3. You switch it. Now we can also take another point. Let's say we can take 6. If x is 6, you have 6 minus 2. So here will be 6, 2. And this will become 2, 6. So let's use these 3 points. So if this is 2, 0 on the graph of F, on the graph of F inverse is 0, 2, which is here. So this is 0, 2. Then if x is 3, 3 and 1 becomes what? 1 and 3. So if this is 2, this point here is going to be 1. So 1 and 3, remember here is 2, right? So 1 and 3, 3 is going to be somewhere here. So we can say that 1 is a little bit 1 and 3. So 1 and 3, 3 can be somewhere here. Then we have 6 and 2, which is 2 and 6. If this is 2, 6 is going to be somewhere up. So this is 2 on this line, so somewhere is 6 here. So it means we need to extend this one. Right? So we can see that the curve is already coming out. All we need to do is to just join the points. So for F inverse, we can just join this point here. So this is a rough sketch of how the inverse look like. It will just move like this and keep going up. So it's a curve. So this is the F inverse of what? Of X. All right. And we can actually verify to see if this makes sense, because we can actually find the inverse of the function, right? What is the function? This is root x minus 2. So if you interchange, if you square both sides, you have y squared is x minus 2. You solve for x in terms of y, x will be y squared plus what? Plus 2. Then interchange, so you have y is equals to x squared plus what? Plus 2. So this is actually our f of x. The inverse is x squared plus what? Plus 2. And you can see that is why it is open where? Open up. It's like an open up parabola. You know, x squared plus 2 is just the complete parts, including this side. But now we need to look at the restriction. What should be the restriction here? The restriction here, which is the domain of f inverse, should come from where? The range of what? F of x. And what is the range of f? You see the range of f is from 0 to where? To infinity. So it means that here, x has to be greater equals to what? 0. So this is the inverse function actually. And that is why you can see we have x squared plus 2. X is greater than 0. So that is why we are taking the right part of x squared plus 2. So we cannot take the left side simply because of the restriction on x. So you see, it means that our graph makes sense. All right. So let's see another example here. This is example 12. This one is asking us to find the interval where the graph of F inverse is what? Lies below the x-axis. So how do you solve this type of question? You have two ways. The one way is to graph F inverse and see where it is below the x-axis. And the other way is just to use the analytical method, which we'll see. So if you want to graph this function, let's say this is f of x. Our f of x is nothing but this one. This is a function that has a vertical asymptote at -2. So it's just going to be something like this. The horizontal asymptote is still 0. And this one. So the graph of f has two parts. Now, if it has to have two parts, it means it has two parts. We can have, let's see, the inverse is also expected to have two parts. But let's see, this is our line. The line y is equals to x. Right? So here, remember this is 0, this is 0, 0. So we need to reflect this graph across the what's the red line. So now if you look at this part, if you reflect this part, if you reflect it across this red line, it's just going to be something like this. Why, if you reflect this one, this part is going to be down here. So we're going to have just something like this. But it's good for us to know the points, actually, because in this case, we need to know some points. So I will suggest we use just points, just take points. So let's take point and see how things work. This is the graph of f, and this is the graph of what? F inverse. So on the black on the graph of f, which is the black one, which side I'm talking of I'm taking this part, which is to the right of the vertical asymptote. So let's take some points that are easy to take. So you can take, let's say you take a point here. This is a point. What is this point? It means x is equals to 0. But if x is equals to 0, put x is equals to 0 into f. You have 0, so you have 1 over 2. So this point clearly is going to become what? Half, comma 0. Yeah. So now let's take some point here. If I come here to take a point, for example, we take -1. We will have -1. If you put -1 into this function here, what do we get? Put -1, you will have 1 over 1, right? So it becomes 1. So it means this becomes 1 minus 1. Okay? So let's plot this graph here. So it means this point is going to be here. So let's call this one half, because this is half and 0. Let me use, Okay, so let's use red points here. Okay. So let's take another point. Let's say here. Another point we can take there. Okay, I think this is okay here. We've taken one here. So let's come to this side. If you come to this side of the curve, we can take a point there. Say we take x is equals to 1. If x is equals to 1 there, which is to the right of half, what is y? Put 1 here, you will have 1 over what's 1 over 3. So it means that point is going to be 1 over 3 and 1. And also, we can also take another point here. Let's say you take 3. So if x is equals to 3, y is going to be 1 over 5. So this is going to be 1 over 5 and what? And 3. So I think we have more than enough points to give us an idea how it should look. Now, we are using points because sometimes it's easier to see with the points, but we can visualize it just like I did earlier, but I want you to see it clearly. All right, so let's transfer the points. Now, 0, half, which is this one, is the same thing as what? Half 0, so which is here. Then I have minus 1, 1. Minus 1, 1 is actually this point. Yes. Minus 1, 1 is going to become what? It's going to be 1 and minus 1. So it's going to be 1. This is 1 and minus 1. So somewhere down here. And then you have 1 and 1 over 3 is going to be 1 over 3 and 1. So 1 over 3 is going to be before 1 over 2. But the y value, 1 over 3 and 1 is going to be up, which is somewhere here. So we're going to have this point here as 1. So then 3 and 1 over 5 becomes 1 over 5 and 3. So you have 1 over 5 is before, okay, let me move this a little. 1 over 5 is before 1 over 3. So you have 1 over 5, and then 3 is up here. So you see that this is just going to be something like this. And it will keep going down. So this is the reflection of what? Of the first part of the graph across the what? Across the x, across the line y is equals to x. And don't forget, look at where it cuts the x-axis. This point is what? Is half and 0. This is half and 0, because if you have 0 and half, it becomes half and 0. So this is the point. And also this, you can also reflect this one. If you try to reflect this part across this line, you should have something close to this, something like this. So it means that you can take points and also do it as well. You will see it look something like this. So here, what does that mean? If you are interested in the part of F inverse, so the blue one is the F inverse. So what changes? You see now, for the F inverse, the vertical asymptote is what? Is the line x is equals to 0. Y for the F itself, the vertical asymptote was what? -2 is -2. So, but since we're interested in the region where F inverse is below the x-axis, all you need to do is take the part below the x-axis. And where are the part below the x-axis? Below the x-axis means less than 0. So you see the blue, this part, everything is still less than 0. It's still below the x-axis. So that is why it's going to be from -infinity to 0, because the whole region here, the F inverse is still below. But union, if you come to this part, you will see that the part that below the x-axis is only this side. So it means you need to stop at this point, and this point is half. So it means it's going to be from half to infinity. So that is the solution for this question. Now, here is a little bit, we can do this one more faster and more interesting. We don't have to graph. What do? So let me do it somewhere here. This is an alternative method. So second method, let me call it second method. Second method is for us to find the what? Find the f inverse itself. So what is f? Our y is equals to what? 1 over x plus 2. So it means that what? It means that I can solve for x in terms of y. So I have xy plus what? 2y is equals to 1. So xy is equals to 1 minus what? 2y. So here x is what? 1 minus 2y over what's over y, right? Then at this point you can interchange x and y. So y is what? 1 minus 2x over x, right? Now it means that your f inverse, the f inverse of x, it simply equals to what? 1 minus 2x all over x, right? Okay, but here we know x cannot be 0, right? Okay. But we want f inverse to be below the x-axis, so it means we want f inverse of x to be less than 0. So what do we need to do? We just need to set this to be 0, less than 0. So it means we want 1 minus 2x over what? X to be less than 0. So this is nonlinear, or we call it rational inequality, right? So how do you solve rational inequality? Here, you just need to do your, what do you call it? The sign test. So we need to do the sign test. What are the critical values here? We have to take 0. And also we have to take what? 1 over 2, right? Because you take the zeros of the denominator and the zeros of the numerator. But don't forget, you have to open all the zeros here. Both of them have to be open because we don't have equal to 0. You need to open at half. Because x is in the denominator, you need to open at 0. Then you can test if this is 1 minus 2x and this is x, right? Take any number between minus infinity and 0. For example, you take minus 1. 1 minus 2x, this will give you positive. This will give you negative. So eventually you have negative here. And this is definitely going to be positive. And this is going to be negative. Why this is going to be? Because if you take, let's say, 1 over 4, between this, so this will be negative, negative, which would be, no, positive, positive. So this is going to be positive. But here, if you take, for example, 1, this will be negative and positive, so it is negative. So you can see that you have negative only in 2 regions. Which region? Here, which is from minus infinity to 0, open. And then from where? From half to where? To infinity, open. So this is an analytical way of solving these questions. So it means you don't have to use the graph approach. You can find the f inverse. And if the question say lies above the x-axis, just instead of using less than 0, use greater than 0. If the question says is on the x-axis, you use equal to 0. Okay, so let me put it here. When you say lies above x-axis, it means you should set your F inverse of X to be greater than 0, lies below X-axis. You should set your F inverse to be less than 0. On X-axis, you should set your F inverse to be equal to 0. All right, so now let's go for the final question here. Example 13. Example 13 is similar to what we did in example 12. But in this case, the question says F inverse is given, right? So F inverse is given. Then you want to find the interval where the graph of F lies below the what? The X-axis. So it's similar situation, but it's just that here you are given the graph of F. So if you want to use the graphical method, what do? You first of all graph this function, but this function is our F inverse. This is just the roots of X plus 9, which is this one, right? But now you reflect it across the Y-axis, so it means we are here. So let's remove the up part. And here is going to be minus 9. So this is actually the graph of what? F inverse of what? Of X. Now, you are interested in the graph of F, so it's still the same story. If you have the graph of F inverse and you want to find the graph of F, it's simply by what? By reflecting it across the what? The Y equals to X. So the reflection of the graph of F inverse across the line Y equals to X will give us the graph of F. Now, if you can do the reflection carefully, if you can see it, it's going to be somewhere here. If you reflect this part, it's just going to be somewhere here up this way. But if you cannot see it directly, take some point. So let's take some point here. Take some point on the graph of what? On the red graph. The obvious point here is what? Is this one, which is, so let's take this now. Remember, it's a point on F inverse. So we need a point on F of X. So here you can see minus 9 and what? And 0. So with minus 9 and 0 is going to become 0 and what? And 9, right? So what other good one we can take? We can take, you can take 0, right? If you take 0, if X is equals to 0 here, what do you have? You have minus root 9. So it's going to be minus 3. So 0 minus 3 is going to be, now how do I have 0 minus 3? I put X is equals to 0 here. But because of this minus here, it's going to be minus root 9. So which will become minus 3 and what? And 0. Excuse me. Now, we can also try to take more points. Which other points can we take? We can take, so we've taken 1 point here. We've taken 1 point on 0 and minus 3. Okay, so it means we took a point, we take a point here. And also we can take one more point here. So let's say 7, right? Because if I take 7, 7 plus 9 will give us what? 16, right? Root of 16, but there is a minus here. So it's going to be 7 and minus 4. And these will become minus 4 and what? And 7. All right. So let's go and put this point somewhere. Okay. So you can see that minus 9 and 0 is 0, 9. Where is 0, 9? 0, 9. If this is 0, 9 is going to be, sorry, this is 0 and minus 9. we just flip it, right? So where is minus 9? Minus 9 is going to be somewhere here. This is going to be minus 9. Remember, this point is what? This point is minus 3, right? Okay, because if x is 0, put 0 here, you have minus 3. Then the next one, if 0 minus 3 is minus 3, 0. Minus 3, if this is minus 9, minus 3 should be somewhere here. So this is minus 3, 0. So this is minus 3, 0. And we also have minus 4, 7. So if this is minus 4, somewhere close, it's going to be up here. So you see how it's going. So it's just going to curve like this. And it will cut at this. So this will keep going up here. So you see the blue one is our what's our F in our F now. So this is our F. And this is F inverse. So now if you look at F, where do we have F to be? Because we want F to what? To be below the what? The x-axis. So F is below the x-axis. Where from this point up to this point. But what is this point? This point is minus 3, right? So it's going to be from minus 3 then until it gets to this point. But at this point, what is the value of x? Y is minus 9, but x is what? 0. So we have minus 3 to 0 close. Now, let's do it now analytically without the graph, just like we did earlier. So remember, we are given that F inverse is what? Is minus this one, right? But we have a condition, x greater equals to minus 9. So let's find the inverse of this function. If you find the inverse of this function, it means you are getting F back. So we'll still do the same thing. Just call this one to be your y, no worries. Just the same procedure. Now you square both sides. This is y squared. It's going to be what? It's going to be just x plus 9. Now x is going to be y squared minus 9. Now you can interchange between x and y. So y is going to be x squared minus 9. So this y is going to be our F inverse of x. So F inverse of x is x squared minus 9. But since there is a condition here, we also need to have a condition on our what? Our F inverse, right? But what will be the condition of our F inverse, which is the domain? You know, this is like, this is not going to be our F inverse now, but it's actually going to be our F because we started with F inverse. So what will be the domain here? The domain here will be the range of what? The given graph, right? Because what is our F? F inverse is what? What is the range of this one? Of the red graph, as you can see, the range is from minus infinity to 0, right? So the range of this is from minus infinity to 0. But we know that the domain of this F is going to be the range of this F inverse. So let me write this down. We know that the domain of this F is going to be the range of what? F inverse, right? But what is F inverse? This is our F inverse, which this function. So it means you need to know the range of this function. And the range of this function is nothing but minus infinity to 0 close. You can use the graph to see it, which is the red one, or you can just do it analytically. When you have a function like this, we know that x plus 9 will definitely be greater than 0. This is always true because it's an even root. Then if you put a minus, you will have x plus 9 to be less than equals to 0. So you see, this is our function. So this is our f inverse of x. You see, it's always less than equals to 0. So the range is from minus infinity to 0. All right. So it means you have to put a condition here that x is less than equals to what? 0. Okay. All right. Now, have we finished? No. Almost there. So, and that is why you see, what is this function? Do you see this function? F is this. What is this? The graph of this is nothing but what? But x squared minus 9 is just a parabola shifted down, x squared shifted down 9 units, right? So it's supposed to be like this. Why? Because x is less than equals to 0. You cannot take the right, you cannot take this side, right? So this side is not included. And here is minus 9, which is similar to, which is the same as what we got here when you try to do the graphical method, taking points, yeah? All right. Now, but we're not using graphical method, so we don't need to know the graph. I'm just explaining this, but now the question is asking when it is what? Lies below the x-axis. So it simply means that you want your f to be less than what? Less than 0. So what we're going to do is we're going to say x squared minus 9 is less than 0. And what is this? This simply means that x squared is less than 9. Here it means the absolute value of x is less than what? Okay, it's less than 3, right? It's less than 3. But you see that x is less than equals to 0. So if x is less than equals to 0, in other words, we're saying that here is what? What is inside the absolute values, either negative or 0, right? So it means if I want to remove the absolute value, what do? We can just say minus x is less than what? Right? It's less than 3. So what does that mean? It means that x is greater than what? X is greater than what? Than minus 3, right? Okay. So now we have x is greater than what? Than minus 3. But we know that x is less than equals to what? To 0. So because we already used a condition, x is greater or equals to 0. So it means that our answer is just going to be from where? Minus 3 to where? To 0. So this is where we can have it. So we just have from minus 3 to where? To 0. X has to be greater than minus 3, but x also has to be less than 0 because of this condition. This condition must be satisfied. So what we have is this. You can write it this way. Yeah. So this is minus 3 is less than what? It's less than x, and x is less than equals to what? 0. So this is nothing but minus 3 to 0 close, right? So this is how to do this without graphing.